Okay, everyone, we'll begin. So thanks all for coming back. It's nice to see you all here again. So we're moving on to week 2 of the Python course, which is a collaboration between UWCS, the Coding Society, and Warwick AI. So today we're going to cover comparison and logical operators, conditional statements, creating functions, and then on the end we'll tag on string formatting, which is a nice way to kind of print your strings without all the plus and whatever you had to do last week. So this will follow on from what you did last week. So if you weren't here last week, quickly skim over what was covered, because we'll use some of those concepts again this week. So we'll start with logical and comparison operators. So first we want to talk about expressions, and we used these last week, but I'm just going to recover them quickly. So an expression is something which is kind of evaluated at runtime and returns a value. So you can see 6 times 7 will give us 42, and then 4,000 divided by 50, it's an integer division. Someone can tell me what that is. I'm not going to risk guessing. So they involve operators and may involve variables or may not involve variables. So we could replace 50 with an integer variable or something. And yeah, we've used these already, but it's just good to kind of recap what they are. So now we'll talk about the Boolean data type. So when you have a program, you often want to do things whether something is true or false. So Booleans kind of encode this. So a Boolean is a true value or a false value. And later we will use this to kind of decide to do something based on a condition. So we can see some examples on the screen of 13 greater than 5. If we were to print this, it would print out true with a capital T and without any quotation marks around it. So the quotation marks show a string, but without the quotation marks, saying true or false is a Boolean, and these are separate types. So we can use them like any other type. So we say the name is Bob, and we call Bob a uni student. We say this is true. And yeah, we can kind of use them like any other value. So now we have Booleans, we can compare Booleans, and we can also compare integers and floats and whatnot using comparison operators. So we see a list here of kind of standard operators. We have equal to, not equal to, and so on. And we can use these to check how values relate to each other, which is something you want to do a lot. We'll go into an example. We'll say if we print 5 is greater than or equal to 5, we would expect this to be true, because 5 is greater than or equal to 5. It's equal to 5, right? So this will print out true without the quotation marks again, as it's a Boolean, not a string. I just really want to get this across. So if we print this one, what do we expect this? We are comparing 2 strings for equality. So we're saying, are these 2 strings the same? It's a common question. We all would like to know the answer, and Python can tell us. It will print false with no quotation marks. And then we have an interesting one here. We say, is 5 equal to 5? Does anyone have a guess at what this will say? False? I think you're correct. So whilst they are the same value, you'll see that one is in the quotation marks and one is not. So one is an integer and one is a string. And although they kind of represent the same information of 5, the types are important. So the comparison checks will take into account the type. Sometimes you can compare across types nicely. So for instance, if we have an integer and a float, and we want to say, is 5.5 greater than 3? This will work. But if we want to say, is 5.5 greater than a string of 3, it kind of doesn't know what to do, because it doesn't know that a string of 3 is a string of 3. It just knows it's a string. So that's just an interesting example I wanted to highlight. So now we move on to logical operators, and we can kind of use these in conjunction with the comparison operators we just learned. So we have and, or, and not as the primary logical operators. And these allow us to kind of join together logical operations. So you can say is 2 plus 2 equal to 4, or is the sky pink or something, right? And you can say this will be true because one of them is true, but we only need one of them to be true, not both of them, and so on. You can kind of see the application there. So we'll move on to some examples using them all. We have like, is 2 plus 2 equal to 4, and is 2 times 2 equal to 4? So some of the like ones who are good at maths among you might have already figured out the answer. We would expect this to print true, because both of these statements are true. Let's look at this one. Is 2 plus 2 equal to 8? No, it's not. Or is 2 plus 2 equal to 4? Yes, it is. So again, this whole thing would evaluate to true, even though one of them is false. And we're sticking only within our Boolean type here. Remember, we only have true or false. There is no intermediate third type or like value. There's only true or false. So now we have a more interesting one using not. The interesting thing about not is not comes at the start, not in the middle. You don't join things together with not. You kind of like apply it to only one expression. And what it does is it flips the value. So if you have a true value, not true would be false, and not false would be true. So we kind of like cycle around here, and we say, is not 2 plus 2 equal to 4? So if we evaluate the inner bit first, and we say, is 2 plus 2 equal to 4? It is. So this inner bit is true. So now in your heads, replace this 2 plus 2 equal to 4 with true. And now we have not true, which we just said is false. So this would print false. So now we have an interesting example. I'd like you all to think about this one. And it shows that you can kind of like join these things all together as you like. So we have not on the right-hand side there. And we have not first or not second. And it's kind of like an interesting one to think about and like get your head around these operators. And then we'll work through it after. But I'll give you all a minute to kind of like think about this. And we also combine it with the variables. So we use variables and then we operate with the logical operators on these variables. So just give it a minute. Have we all had a quick look at it? Anyone got an answer that they'd be willing to share? I can't tell you immediately if you're right or wrong because I've forgotten. So we're going to work through it after, but anyone got a guess? You can say anything. You can even guess. True. True? You think it's true? Okay. All right, let's go with that and let's see what happens. So first, I'm going to look at the individual kind of variables we have. So we have first equals red equals yellow. So this is saying, is red equal to yellow? And this is false. The second is saying, is 8 times 8 equal to 400? I don't think so. So I'm going to say again, the variable second is false. Third is claiming that 1 plus 1 plus 1 plus 1 is equal to 4. And this is true. So we have false, false, true for our variables. So I'm kind of going to start at the innermost section, remembering that kind of like evaluation follows what we learned in kind of secondary school or lower school with BIDMAS. It's kind of works the same way. So we're going to start from the inner parenthesis here, saying not false or not false. So that is essentially true or true, which itself is true. So I think this whole first kind of inner statement is true. So then on the left-hand side of this and, which is kind of like joining this side and this side, we have not true. Okay, so let's do one of these nots and apply it to the true. So we have false, but then we still have a not left. So we have not false. And then we're going to do that again, and we're going to get back to true. So I'm going to claim that this left-hand side is true. And now the right-hand side, we said third was true, and then we're going to do not true. So if we kind of like flip it a few times, not true is false, not false is true, not true is false, and not false is true. So I'm going to claim again that this side evaluates to true. So ultimately, we end up with true and true, which is then true. So I think you're correct, whoever said true. Well done. And well done to anyone else who got the answer. So we're going to move on to conditional statements, which will allow us to use these Boolean variables or values to make decisions in our program. So an important kind of construct, and the main construct here is the if and else statement. So we can decide to do something depending on whether a statement evaluates to true or false. So hopefully you remember typecasting and input from the first session, but essentially we ask the user to enter the age, the input function will give us the age as a string, so we change it to an integer so we can do the comparison. And then we check if the user is old enough to enter the pub and let them in or tell them they can't come in depending on the age. I think it reads quite nicely. You check if the age is greater than or equal to 18, and then kind of on this inner indentation level, so you would press your tab key here on the keyboard to kind of like denote that you're inside this case. We call it a branch. So if you're in this branch, you say you can enter the pub. And then we have else, which is kind of like otherwise, or like if this first condition isn't true, do the second thing, which is we say you're too young. We also have this thing called elif, which is like a little tricky one, but it allows us to do multiple checks. So if the age is greater than 18, like maybe we're a fancy pub and we have a restaurant. So like if the age is greater than 18 or equal to 18, you can enter the pub and drink. If you're 16, you can enter the pub and not drink. And if you're 17 but not 18, you can enter the pub and not drink. And otherwise, we say, sorry, too young. The interesting thing here is, if I enter 20 as the age, you'll notice that both this and this case, so the first and second cases, are both true. So you might think, we print twice. You know, if the age is 20 and we match both cases, do we print twice? Do we tell the user they can enter the pub and drink and enter the pub and not drink? We don't. And this is the tricky thing about elif statements. So they're executed from top to bottom in the list, and as soon as you match one, the rest of the conditions don't get checked, and the rest of the branches cannot run. So you can only run one branch. So I would like you to think, if I flipped the 16 and 18 here, and I flipped the order of these branches, if I enter 20 as the age, the first check would say, is the age greater than 16, greater than or equal to 16? And it would say yes, and then it would never check the rest. So it would tell everyone they can't drink, even if they are old enough. So it's really important to consider the order of your statements, and you think about it as you want it to happen. Another important thing about if statements is you can nest them. So here we have an application which maybe lets a parent sign their child up to YouTube. And if the age is less than 13, we give them the option to put it in parental mode. And they can say yes or no using our bool data type here. So we do a typecast to bool. And if they said yes, we let them onto YouTube Kids. And if not, we let them use the real website. So this is just highlighting that you can kind of merge if statements and all these constructs together. So like if you have an if statement, inside the branch, you're essentially writing a new program just knowing that your condition was true when you entered this program. So you can kind of use everything everywhere. And it's just important to kind of highlight this. So now we have this really long match statement. But the nice thing about this, or about match statements, which are kind of the same thing as if statements, but they offer a different way of writing it. And the nice thing is you don't have to repeat yourself a bunch. So here, we ask the user to enter a month number. And depending on the number they input, we tell them which calendar month it corresponds to. So if they enter 12, they get December. For 1, they get January, and whatever. So if we would think about writing this as an if statement, we would have to say if month num equals 1, print January, elif month num equals 2, and we repeat month num a bunch here. So this kind of syntax or way of writing lets us ignore that and just say case of 1, case of 2, matching over the month num, and then it will go into the correct branch, remembering that a branch is kind of like these indentation levels, depending on the value of month num. And the other interesting thing is the underscore. So say the user entered -5, or they entered 5 million, or whatever, we would say not a valid month. And the underscore kind of captures all cases not covered otherwise. And again, it's important to note that you will only enter one branch here. You won't enter multiple branches. So if you're month number 1, you won't end up printing February, March, or everything else. You kind of just enter that branch, and then you exit the whole match statement. You can also kind of group numbers. So sometimes on certain inputs, or a certain set of inputs, you would want to do the same thing. And we can kind of like, the aim with this kind of syntax is to reduce how much code you write and be able to express what you mean in fewer lines of code. So this allows you to do that by grouping cases together. So here we have a response code, which we can think of as like an error code. And we print the kind of, if we recognize the response, and then we use underscore again to catch if we don't. So if I have 500, 501, 502, and so on, I would end up in this branch. And this is kind of some nice syntax to handle this. So we'll move on now to functions. So we've used a lot of things like print and input already last week in the exercises, and you saw them in the lecture. We can also write our own functions. So print and input are functions, and there's something like kind of like a magic black box, and we write it with some curly brackets, and it just nicely does something. We can kind of write our own versions of these, so we can write our own thing that we can call with curly brackets or parentheses or whatever, and it will do something as we told it to. And you can imagine like if you wanted a function to check out the basket, or you wanted a function to process payment or let a user log in, and it allows us to group and reuse code. So like maybe you have a condition you want to check lots of times throughout your program. Maybe your program takes a long time to run, and you want to keep checking at various points if we're past 6 p.m., and if we're past 6 p.m., we want to give up. So you can have a function to check this instead of copy and pasting the same code every time, because if you decide you want to change it to 7 p.m., you would have to go back and change it at every single point. Whereas if you have a function, you only need to change it in one place. And like when you start writing, some code bases can come to millions of lines of code, once you're writing really, really big projects. So they really, really help like group things together and make it more maintainable and readable and understandable. So you use this syntax with def to say define, and then the name of your function, followed by curly brackets or parentheses, and then a colon, and then you go into kind of like an indentation level, kind of like a branch, and everything at this level is part of this function. And then when I call greet down here, it's essentially as if I copy and pasted print hello here. There's some like slight differences we'll see on the next slide, but it will print hello. So yeah, we're going to talk now about parameters, which are something you can give to your functions to allow them to take values. So you notice when you type print, inside the curly brackets, inside the parentheses, you put a string to say what you want to print out. And in input, you put a string of what you would like to ask the user for. Function parameters let us replicate this for ourselves. So we can tell it to greet somebody specific. So we can define our function greet person, and inside we put a variable name. And then inside this whole scope, inside this whole kind of like indentation level branch, we can reference this variable name, and it will be filled in when it's actually ran with what the user gave it. So we can call greet Alice here, and it will say hello Alice. And then when we call greet Bob, it will say hello Bob, and so on. An interesting thought is, and I'm not going to tell you the answer, but maybe try it later, is what will happen if I pass greet 5? Will it work? Will it not work? And why? It kind of goes into what we learned last week, but I thought it's an interesting example because it shows that you can pass anything into functions in Python, even if it's not what the function would expect. So when you write your functions, you should keep this in mind. Functions can also return values. So when you use the input function, sometimes you assign to a variable. So sometimes you would write name equals input, enter name. How do we get that for ourselves? I would like that, So we can use this return syntax, which returns something from a function. So our function defines what's called a scope or a block or an indentation layer. And within this, we have access to the variable here. And then if we want to pass something outside of this, so when we get back to our regular program after calling the function, we can return a value. So here I have defined a function to square a number. I pass in square 1,000. It gives me back, it returns whatever the square of 1,000 is, a million or whatever. And then the same with 42. And we print this out. but we could also assign it to a variable. We could times it by 2. It's as if we had the actual value here. So functions are able to do that. And you can combine this with your if statements, so you can decide to return a square if it's even, or multiply it by 2 only if it's odd. You can do things like this. And these are actually, the examples I'm giving are quite contrived, but you can do whatever you like with them. I think we have an example on the next slide, maybe. So yeah, here we have a spy login, okay? So like you can imagine you've got like some, I don't know, like computer in the wall or something that people can come up and use. And it asks them for their name. And then if they type in their name, like if I type in Alfie here, I will say, is Alfie equal to James Bond? Unfortunately not. So it's going to go down this else path. And then all this is going to do is call this function, passing in Alfie, and it will say, hello, Alfie. But if I did type in James Bond, it would say, hello, Mr. Bond, Like it would go into this path at this level. And you can see that there's differences in what the paths of the if statement do. One of them passes an argument, one of them doesn't, and so on. And I'm just kind of trying to show here that you can really, really use these to do whatever you like. They're just basic building blocks, and what you do at each level is really up to you. So yeah, functions can do anything that you've done so far, and most of the stuff you'll learn in the future, you can put inside a function to kind of like containerize it and keep the concerns there. So we'll move on now to string formatting. It's just like the last slide and last part. The conditional stuff is the main focus of this kind of lecture, and is what most of the exercises will concern. But I just wanted to show here f strings, which allow you to kind of like nicely print formatted strings. So like we have this thing called a string literal, which gets referred to on the slides, and I just wanted to show what that is. A string literal is just a string, some string. It can contain anything, but it's just kind of like a hard-coded string. And then variables, we often want to print them out. So like we want to say someone is the president of some society in a print statement, and we use this plus, and we have to open and close the string, and it's really awkward. And what if it's an integer? Then we have to typecast it, and so on. So like down here, f strings let you avoid all of this. You can print out what you like just by putting a little f at the start of your string, and then using these like braces, which you get to print them out. So they're just like a cool little thing I thought I'd put on the end, so you can use them when writing the programs in the exercises. And yeah, that is all for this week, this week's lecture. But if you did miss the lecture, it's all written down in the worksheet, so you can read through what I just spoke about and then do the exercises as well. Yes?
So I was just wondering, where's the worksheet?
The worksheet is on the Google Drive, linked to here under week 2. So if you go to this URL and then week 2, it's the same as it was last week, a Jupyter notebook.